Welcome everyone to an exclusive webinar focused on one of the most transformative shifts in the telecommunications landscape, the evolution to 5G virtualized radio access network architecture, and the indispensable role of automation at scale in this journey. As the world eagerly anticipates the promises of 5G technology, telecommunication service providers are facing unprecedented challenges in adapting their infrastructure to meet the demands of this new era. The advent of vRAN heralds a paradigm shift promising unparalleled flexibility, scalability, and efficiency in network management and service delivery. Here to take us all on the journey of unlocking the full potential of 5G vRAN networks is Phil Rackus, Senior PLM Cloud Industry Verticals at Wind River.
Welcome to this webinar presentation of Automation at Scale for 5G vRAN. My name is Phil Rackus, and I am going to be your presenter. Operator revenue will grow at 1,400% over the next 2 years. That's a kind of provocative statement. And our webinar today is really going to dig into that statement, where we're going to try and see whether or not we think that that's a true statement, whether we believe it, and assuming we do, how we capitalize on it. That's really, I think, the important part here. And in order to do that, we're going to go through this agenda. So we're going to talk about the drivers behind virtualization and automation of the 5G network. We will introduce you to the Wind River automation solution. We're going to use that as the context to discuss day 01 and day 2 type solutions. And then we'll look at some real world case studies and talk about our customer base a little bit and put a little color to the conversation. Before we do that, for those of you who are not familiar with Wind River, we are an Aptiv company. We were acquired by Aptiv approximately 1.5 years ago. If you are not familiar with Aptiv, they are a leader in intelligent and connected vehicles. So that will all make sense in the context of Wind River as we go through what we're doing here with respect to virtualized far edge infrastructure, and so let's continue with that. So there's a lot of facts here about Wind River. I'm not going to go through all of them. I'll go through some of them, the ones I think that are most important. First of all, we are number one in edge operating platforms. So what does that mean? It means if you connected to the internet through a cell phone or a smart device today wirelessly, there's a better than not chance that you connected through a Wind River enabled device, because there are more than 2 billion Wind River powered devices powering mobile and wired networks around the world. We are a global leader in delivering software for intelligent connected systems. We are a trusted partner for customers who require mission critical solutions and the servicing of those mission critical intelligence systems. We have award-winning customer service, a broad partner ecosystem, as well as world-class professional services. And we are headquartered in lovely Alameda, California. We have more than 1,600 employees, including 600 that are actively engaged in research and development. Our customers include top companies in the aerospace and defense, medical, industrial, telecom, automotive, and mobile and consumer space. Simply put, when customers need it to work, Wind River is a trusted partner to deliver that solution. We are a global company. We have offices across North America, Europe, and Asia. This morning, I am coming to you live from lovely Canada, outside of Ottawa's nation capital. And our customer base, specifically in telecommunications, because that's what we're talking about today, as I mentioned, 2 billion plus devices powered by Wind River today, mostly in the 5G RAN space. Our customers include Verizon, T-Mo, AT&T, Vodafone, KDDI, TELUS, NTT Docomo, Siemens, Alisa, to mention a few. Okay. Gotten through the preamble. You know who we are, you know who I am. Let's talk about this particular question in front of us. 1,400% increase in operator revenue over the next couple of years. So as I said, that is a pretty provocative statement. Now, where would those revenue growths be coming from? So they would be coming from a combination of things, really. They'd be coming from a redefinition of what we classically think of as a subscriber, as well as new ways that our existing and new subscribers are going to be consuming services. So in the old days, a subscriber was somebody with a cell phone, and they would consume our services by placing a call or sending an SMS text. Now they are doing those same subscribers are doing vastly different things. They are streaming video. They are engaging in video conference calls. Some of you might be connected wirelessly today on this call. They are doing a lot of things like gaming, VR, augmented reality, things that you might have considered to be more in the realm of a fixed access network before. So in some senses, you can look at a modern next generation wireless networks as replacing and supplanting those fixed access networks in terms of the way that consumers consume applications and content. That's cool. But then there's all kinds of other ways that these services are being consumed, or services are being consumed over the internet. And we're really starting to talk about the Internet of Things. We're talking about logistics information, where vehicles, both cars, trucks, drones, so on and so forth, are sending telemetry data and conversing back and forth with command and control systems. We're talking about V2X, automated driving kind of applications that are coming around the corner, where cars are using the network to communicate with each other in order to maintain safety of the roadways, but also to kind of coordinate the efficiency of the roadways. That's kind of cool. Telehealth and medical services with wearables and connecting resources and patients and doctors and labs to bring all kinds of specialized expertise and capabilities to bear for patients wherever they may be. And of course, that has a very meaningful impact on people's day-to-day lives. So all of this stuff is very cool. And it really speaks to a convergence of industries that didn't used to be especially converged, whether that is logistics, whether that's health services, whether that's industrial applications, and of course telecommunications and mobile specifically. So all of these new service offerings, which are going to drive the new revenue, clearly, are going to bring with them a host of drivers. I think first and most obvious set is that these are very different kind of services. So they are going to require new edge capabilities, and we can't necessarily know what those are. So at the moment, so the question is how capable are we of being able to adapt to these new changes as they become apparent on the horizon? So agility is important. A lot of these services speak to a high degree of availability, performance, latency, and determinacy. There's a big difference between somebody's voice call being dropped, the old "can you hear me now" kind of thing, versus extended delay on streaming their video, versus a lack of accurate telemetry data on a moving car traveling 75 miles an hour as it hurtles down the highway. Really, really different risk profiles associated to all of those things. In some of these cases, you'll have an upset customer. In other cases, you might have a dead customer. So, this creates all kinds of drivers for self-managing, self-healing, 6 nines availability, kind of a real-time deterministic view of performance and latency. But it also speaks to agility, and that drives software hardware disaggregation. It also drives kind of the ability to get new services into the pipeline and through the pipeline into production very quickly. So that these drivers start to push us to some very specific kind of directions. what we think of as CT/CD, continuous test, continuous delivery, DevSecOps kind of mindsets, really focusing on how we get the most out of our vendor hardware capabilities, especially when we're selecting those vendors very specifically. How we are aligning the resources and capabilities of our core to edge in order to maximize scaling, maximize capability, maximize availability, but also maximize cost, because profitability matters too. And then getting down to that real-time deployment. How quickly can we expand our network? How quickly can we roll out new capabilities? All of this is how you attack that 1,400% revenue opportunity that's coming down the pipe. So what is important when we're talking about the edge specifically? What is really important? What kind of characteristics do you need to be highly focused on? Well, these are not in any particular order, but again, when we talk about some of these new applications, logistics, and so on and so forth, having that really low latency communication between the application and the edge node, with a high degree of deterministic measurement, so that you can consistently rely on the amount of delay that you're seeing. That is key for these applications to work. A small footprint. It's one thing to have a node or two dedicated to management in a core network service or core network data center where you have hundreds of nodes. It's okay, right? I mean, maybe it's not great, but it's okay for you to have a node or two dedicated to that. But when you're talking about an edge site where ideally you only have a node or two or three or four, to dedicate a node or two to management across 50,000 nodes, well, that's 50,000, 100,000 systems dedicated purely for management, plus heating, plus cooling, plus powering up, plus management. It becomes an expensive proposition. So having that ultra low footprint, especially for management, is key. Really simplified day one and day two operations. I'm not going to talk much about this because we're going to talk a lot more about it, but you can clearly see that the ability to get things into your cloud and keep them life cycle managed quickly to the version you want, to the capabilities you want, is how you're going to get all of that good innovation. The literally billions of dollars your vendor community is spending, and the millions of dollars you are spending to integrate and validate those capabilities, that is how you're going to get that into the market quickly in order to be competitive. Reliability, I think it speaks for yourself. We know the telecommunication networks need to be reliable. Clearly, as we start to put these new types of services on top of them, they need to be even more reliable. We make that move from 5 nines to 6 nines. Scalability. Scalable means scalable down as well as scalable up. So we tend to think more on scalable up, but in this case, it's also important to be scalable down. And then thinking about what scalability means in the context of an edge network, where it's not so much about, can I have a cluster that can manage thousands and thousands of nodes, or even hundreds and hundreds of nodes, but can I have a construct that aggregates together hundreds, thousands, tens of thousands of small sites. And then finally, edge security. The edge of any system, the edge of any network, is a point of attack. So, making sure that your partner here is putting a high degree of emphasis around creating a very solid security posture is going to be key to keeping your network secure, and that's going to speak to all this other stuff. So that is that. So our solution, and suffice it to say, our solution supports all of the characteristics that we just talked about, but our solution is focused around Wind River Studio Cloud Platform. It includes Studio Analytics as well as Studio Conductor. So Studio Cloud Platform is our Kubernetes distribution plus. Studio Conductor is our automation analytics framework, and Studio Analytics is our data collection, data exposure, data mediation systems. We'll talk a little bit more about some of these things. Here we go. So In some sense, cloud platform is very similar to any other Kubernetes distribution. It abstracts the processing, the memory, the I/O, and so on and so forth from the containerized applications. It provides an orchestration layer for the deployment and management and monitoring of those things. So in that sense, it's like any other Kubernetes distribution that you've seen. And where it differs is that it is really geared towards the far end. So that means that it really does, it creates a concept that is a logical aggregation of many clusters, right? Many small clusters into something we call a distributed cloud. And that allows you a capability to manage those things in a way that is more cohesive, because you really can't manage 50,000 or 100,000 small edge clusters on a one-off basis. That's just not, it's not practical. It's not viable. And of course, our solution is fully managed, fully supported, fully integrated, not just ready to deploy, but it has been deployed and is currently running the largest production virtualized RAN networks in the world. Our orchestration and automation platform, Conductor, it is a multi-domain orchestration automation. And while it is clearly focused on managing our own cloud platform, it extends, its capabilities extend beyond that. So including infrastructure discovery and management, CaaS deployment, others, lifecycle management, workload deployment, public, private, cloud, hybrid cloud models, support for lifecycle operations from deployment to upgrade and update. We'll talk a lot more about that later. It is built with standard APIs to interoperate within a typical telecommunications infrastructure. So support for Etsy Nano interfaces, CSAR packages, SOL 001, 004, and we'll shortly be rolling out support for O2 IMS interfaces as well. I'll talk a little bit more about what we're doing in the context of ORAN as we proceed through this presentation. And then driving AI optimization to improve efficiency, effectiveness, availability in conjunction with our Wind River Analytics product. There's a whole other topic here, so I'm not gonna drive into that at all today, except to say that it is there. So I promised to talk a lot about some of these lifecycle management operations, and that's where we're going to start now. So we're going to start with day zero, day one operations, and I'm sure most people on this call are aware, know what those indicate, but just in case you're not, day zero and day one really refer to the things that must happen before you launch a single subscriber onto a service. So things like, getting the hardware racked and stacked, discovering it, creating an inventory, and making sure the configuration is up to date and appropriate for the service you want to roll out, getting your CaaS layer deployed, getting your workload loads deployed, getting everything configured. Only then are you actually ready to start deploying subscribers onto it. So that is really what we mean by day zero, day one. And let's break that down a little bit. I'm not going to go into the racking and stacking of the hardware. I'm sure you guys know how to do that. But where big problems tend to start is really when you start to go about the deployment phase of this. And the reason for that is, and I'm sure for those of you who are already doing these kind of deployments or planning on it, you really do have a plan in place or a process in place to make sure that hardware is kind of factory configured, let's say. It leaves your site, your central site, ready to go. It's been set up with the right BIOS configuration, the right operating system, the right patch level, blah, 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 right? It's ready to be deployed. But unfortunately, for whatever reason, for any number of reasons, a percentage of those servers that are going out will actually fail the deployment anyway. And some of the reasons for that are obviously human error, change in planning, right? You had planned to put a Mavenir node, and then somewhere along the line you changed and now you're putting a Samsung node or an Ericsson node, and that's going to require a slightly different configuration or a degree of drift between the time you actually pre-configured the hardware in your factory till the time when the actual deployment occurs, right? There might be some change, an upgrade in BIOS, a new operating system patch version, a new CaaS update that needs to be deployed. So even if you get everything right, it can still not be right by the time you get there. So really the key is to have a system that is resilient to change rather than rigidly enforces consistency. And in this way, you can kind of get the highest possible success rate of your deployment. So we start by retrieving the configuration, discovering the hardware that's there. So, in this graphic, you can see that there is conductor. It is a singular instance. It's deployed, probably deploy that somewhere in a central site, probably not too far from your OSS and BSS systems. So you very well might be getting that configuration coming down from an inventory system or a service designer. Conductor does speak a Tosca-esque dialect, so that's pretty straightforward. As I've said, we're supporting the Etsy, Mano, Sol interfaces. So in there's going to be some management IPs for the hardware that you want to deploy on. Right. Okay, good. So we inventory that configuration, and I'll use type site or the term, excuse me, site rather generically, but really I mean everything that is there. The hardware, the operating system, the BIOS, the CaaS, the application. So all of these things need to be configured. And obviously they're somewhat independent, but they all need to be configured for that site to behave. So, discovering the hardware configuration, discovering the CaaS configuration, discovering the workload configuration. So all of that's coming to us from that central site. So good, we have that. Now we know it. We are going to build the configurations for the individual components that sit within the site in the way that those systems expect them. Then we're going to actually do the discovery. So we go down, find that hardware, find that management IP. Maybe we'll do this directly through a Redfish API or some such on the hardware. Maybe we'll do this through an equipment manager like Dell BMO or HPO or something like that, or OV, something like that. In any case, we're going to discover the hardware. We're going to compare the configuration against what we expect the configuration to be or what it needs to be. And if it isn't what it needs to be, then to the best of our ability, we're going to correct that. Now, obviously, if a hard drive was missed or a processor was missed, there's not much we can do that. But if the BIOS is the wrong version, firmware is the wrong version, something needs to be patched up, it can be, and we'll do that automatically. And that gets us into a position where we can now start to deploy. And in our case, as I said, we have we have this layer, this management layer that starts with something we call the system controller. So we deploy that, and then from there we deploy the individual Kubernetes clusters, the subclouds after that. And then once the central controllers and the subclouds are deployed, then we can actually go and deploy the target workloads. And then just like that, you're kind of up and running. So let's have a look and see what that looks like in practice. So in this demo, we are going to go through a day zero, day one kind of model. So you're going to see this in action. It's going to go fast. So what I want you to be paying attention for is the degree to which automation is taking over here. And the other thing I'll point out is automation can actually it could be even more automated than this, but unfortunately that doesn't make for a good demo. So we have kind of broken up the automation so that you can actually see some things occurring. But I want you to be watching for how you observe the day zero, day one operations, because, again, it's very different when you're watching a cluster deploy versus watching 1,000 clusters deploy. You need a different level of observability. And then I want you to be thinking about how this kind of capability would allow you to rapidly roll out new services and new capabilities to your network. So I'm going to bring you back to this slide periodically just because we are going to be moving very quickly and I want you to be able to track to what's going on. So in the first sequence, what we're going to be watching is the creation of the site configuration. So we're going to be, this is going to come in two parts. One is called the CIQ, the Customer Information Questionnaire, and the other part is the golden config. So the CIQ is all about the specific detail necessary for a targeted site or one or more sites, whereas the golden config is a policy construct. So it's the generic information that all of the sites will be set up, whereas the CIQ is the specific IP addresses, the specific items that need to be configured uniquely and identified uniquely for a particular site. And then all of that will be created and saved. So let's see how that goes. First, we're going to log in. And we're going to commission our secrets. So all of this, because there are passwords and things like that in here, that it does go into a vault. So we will load our blueprint. We're going to do 1,000 sites here. So we have our golden config on one side. Now, as I said, you can do this in any number of ways. Conductor doesn't really care where it's getting the source information from. It could be from a descriptor, could be from a northbound inventory system. In this case, we're just using something as simple as possible, which is an Excel spreadsheet. So there is our CIQ information. So what it's going to do is it's going to combine these two pieces of information. So let's load that blueprint. It's pretty straightforward, generating the batch secrets. Okay, we can see that some things are occurring. And if we go over to our secrets, we should see some files starting to appear. And that is where our individual site files are going to be stored. So if we look into one of them, just as an example, really it's just to illustrate here how our site config on the left, you can specifically point out the OAM subnet that we're pulling from the CIQ, and you can see the DNS server information we're pulling from the golden config. Literally every single piece of information that is in the site config is being pulled from a source or another. So off we go. Next, we are going to audit and remediate any issues that we find. So we're going to load our audit blueprint, and we're going to pick some target sites here. And it's going to go do the blueprint now. As it's doing the audit, as I mentioned, it's going to be looking for things that need to be remediated, and then it is going to be automating that process. So what have we got going on here? So on the right-hand side, we have iDRAC9. So those of you that use Dell hardware will recognize iDRAC as being the BMC interface on the server, and we have Conductor on the left. So clearly, it looks like a firmware update job was required. So we see that has been tasked. Things are happening on Conductor. And if we look over, we should be able to refresh our iDRAC, and we see, yes, the BIOS version has been upgraded to 2.17. So in this way, we can automatically take care of a wide range of problems just like this, whether it's configuration or BIOS or patch level or what have you. And now we're ready to deploy our subclouds. So in this particular demo, the controllers are already deployed. So in this case, the provisioning of the subcloud occurs through the controllers. So we're going to pick the sites and define the controllers. And then when we do that, so there's our controllers, they are simply going to be deployed. So we'll keep an eye on that. And then we should also be able to see them. Oh, I'll mention this. So the task graph shows the specific activities. And then as they start to become active, they appear on the geomap. So anything that is blue is ready to go, is active. So now that these things are all active, we can go and deploy our workload. And we are using an Intel FlexRAN node. So we'll go and we'll do that. Now that we have these things associated to controllers, we can simply choose the controllers if we so choose. There are lots of different ways of doing that, but this is the easiest. Off we go. And we see that we now have one workload package on each of our sites. So excellent. And it is really as simple as that. We should also see our geo map, 500 workloads deployed on 500 sites. There we go. So now we have a fully capable network that leveraged a high degree of automation, and that automation allowed us to streamline operations, save time, energy, which reduces the amount of effort required to get these things deployed, which is part of the underlying work that is required to become really an agile organization that is capable of getting new capabilities to the market quickly. But it's only half of it. The other half is the day two operations, because of course, it's not just about getting a capability to the network. It's about making sure that the innovation that your vendor community is bringing to bear in subsequent versions of the CaaS, subsequent versions of the vRAN nodes and the other workloads that you're going to deploy at the edge, those things are being brought to the customer base as quickly as possible, as quickly as you can run them through your pipeline. In some sense, is kind of the objective. So day two operations, for those of you who aren't aware of that term, it really is the things you need to do to upgrade and update your network. And clearly, there's a lot of similarity, yeah, it's not the same, but there is similarities between obviously doing a deployment and doing an upgrade. One of the biggest things I would say that at a fundamental basis makes it very different is that unlike day zero and day one operations, where there are no subscribers on the network, there are subscribers, live customers on your network at this point in time. So that means that there is a maintenance window, and you need to be abide by that, by the time limits within that. So there's more planning involved, and a little less tolerance for failure, because then you have SLAs and so on and so forth, and that gets messy. So what are we talking about at a high level? Well, we're talking about making sure that your network is ready to accept the patch. We are making sure that we are ready to push the patch. And then there's actually pushing the patch or the update. And then there's dealing with the inevitability that there's one or two nodes or some percentage of nodes that don't properly upgrade, and getting all of that done by the time that maintenance window kind of concludes. So validation of the environment, just like we had to do an audit of the hardware before we push the patch, we need to validate the environment again. The new version of workloads, for example, might have different requirements on BIOS. They might have different requirements on CaaS capabilities. There might be some new CaaS capabilities that need to be rolled out. So you might need to upgrade the CaaS. There might be some impacts on the Kubernetes clusters and the subsystems. So all of these things need to be checked and tested, and it needs to be done in a way that is extensible, because even though there's a lot of commonality, let's call it the 80-20 rule, or whatever you want to call it, your network will have some idiosyncrasies that will require some validation that is very specific to you. So allowing it to be customized and tailored to you is really important. And once we've got a network that we understand to be ready for an upgrade, we need to get ready for the upgrade. So there's a few things that are involved with that. So the first is defining your policy. How many upgrades are you going to do at exactly the same time? How much parallelism are you introducing? How many retry attempts should the system execute before it concludes that a particular node is not going to upgrade? Are there any execution group rules? Think of like affinity rules. Like, I don't want two subclouds side by side to be upgraded at exactly the same time, because that might cause a service outage. I don't want a service outage. Okay, good. So those kind of execution group rules. Pre-staging the updates. So depending on the size of the update and how many components are being updated, the download of the software could actually take quite a bit of time, but that doesn't need to happen during the maintenance window. So all of that software can be pushed down in the days or even weeks leading up to the maintenance window, and validated, pre-validated, that the versions are right, and that the software wasn't corrupted as part of the download, and so on and so forth. So that can all happen before. So that's all part of preparation for the update. And then finally making sure that you have a backup of just in case, right, of the systems being updated, the configuration is there. So if you need to restore from backup, you are capable of doing so. And then, once the maintenance window arrives, we need to actually do the update. So there are a lot of different moving pieces here. I mean, obviously, there is the hardware, there is the firmware, there's the BIOS, there's the configuration, there's the operating system, there's the operating system patch level. There is the CaaS software, there is Kubernetes, there is storage software. There might be some other components, let's call them CaaS type components that have been deployed. And there's a particular order and sequence to how these things must be updated and upgraded. There is a sequence and knowledge of when reboots must be applied, which components can be batched together before a reboot is applied, because reboots actually take quite a bit of time. So, you don't want to be needlessly rebooting. We do this in a declarative way, so that has a number of benefits I'll talk about later, but it simplifies things. Let's just say that it simplifies things because all you need to do is tell the system what is the end state you're interested in. I want everything to be running 824.03 level. Okay, good. It will figure out where everything is today. It will figure out what needs to be upgraded, the order of upgrades, the reboots necessary, and it will make that happen. And you don't need to be worried about it. Your northbound systems don't need to be worried about it. That's important too. And then the parallel operations and the horizontal scalability of the system really allows your network planning to drive your deployment scheme rather than system limitations. And that is important because, if you want to upgrade 100 nodes at a time, you should be able to do that. You shouldn't be limited to 25 or 10 or what have you, simply because that's what the system can do. All right. And as much as I would love to tell you that everything is going to upgrade all of the time, that isn't necessarily true. Obviously, we are going to do everything in our power to maximize the success rate. We're going to do that by, being intent-driven, right? The simpler we can make the process from an externalized perspective, the less human error there's going to be introduced and the less failure you're going to see. By having that same simplified process applied on the northbound interface is going to reduce the amount of time, effort, and energy necessary to get your northbound systems set up to work with the subclouds in the cloud and the distributed cloud. And that's going to allow you to do this faster and pivot easier. That pre-validation we've talked about, obviously, if we can make sure that we're eliminating failures or potential failure scenarios beforehand, that's good. Automatic retries are going to filter out those, didn't work this time, but if we try again, it's going to work, which is a lot, by the way. And then automatic rollback. If all of this stuff fails, automatic rollback, which is why we did that restore, remember, is going to reset that subcloud back to the state it was before. So, even if the other 1,000 or 999 all succeeded and that one fails, at least it will still be working come the end of the maintenance window. And that's important. All right. Let's see this in action. So day 2 operations at scale. So, similarly, right, you are going to see fast and predictable upgrade of the network. You're going to see observability that is geared towards watching volumes of subclouds upgrade rather than just 1 or 2. You are going to see a high degree of automation that's going to create operational resiliency. And you're going to see how this simplified approach makes it cost effective to go through an update or an upgrade process. And that is key because if it's cost effective to do it, then you'll be more willing to do it more frequently. And if you're willing to do it more frequently, you'll get more features to market faster, a better security position to market faster. You'll be more competitive in the market, and you'll be in a better position to attack that 1,400% revenue opportunity. All right, back to our slide. So what are we going to do here? Again, in our first step, we're gonna look at that pre-check blueprint and see what that looks. We're gonna load that up and get that ready. So let's go do that. Our pre-check blueprint. It comes from the marketplace, which is our internal repo. So these things are geared towards particular releases. There's a high degree of commonality between releases, but there are some things that are specific to a particular release. Now, within our blueprint for this demo, we've got 5 different blueprints. Now, it is very easy for you to configure these. Each individual pretest is really it's written in Python, so there you can edit them to configure or tune them for your network. It's also basically a file store, right? So it's a directory structure. You can add in new tests as needed to accommodate your network. I don't want to use the word peculiarity, but maybe it fits. So it is extensible and customizable. All right, so we have our uploaded blueprint. And now we're going to use that blueprint to check a list of sites. So the first thing we need to do is to create a group of sites. Now, we could do this in a couple of different ways. So when we did deployment, I showed you just basically using all of the subclouds associated to a particular controller. That's one way of doing grouping within Conductor. Another way is to use deployment groups. And a deployment group is really a flexible and dynamic grouping that is based on the labels that are applied. So you just select the labels that you want to be part of the group. And as long as those labels appear on a particular subcloud, it becomes part of the group. So you can see how that could be very useful. This is a very simple example, right? But you could have labels attached to your subcloud that correspond to the region, the target workload, the current version. That would be very useful. And then as you upgrade it, for instance, you would remove, as part of that upgrade process, you would remove the previous version and add a new version, and it would exit one deployment group and become part of another deployment group. And that way it's very dynamic, so it becomes very useful as an ongoing model. So I just wanted to point that out. So we've got our pre-check or our deployment group. We're going to use that to check our pre-check the nodes that fit within that. So we're going to have a look and see. We're going to run that. So our deployment group, pre-check group A. There we go. And we can go to our dashboard. All right, what are we looking at here? So we see the deployment sites. So there's a total of 101 sites that met the criteria for that deployment group. And on each of them, we are running the 5 tests that we talked about before, and we can see that they all pass. So that's good. If we drill into one, Chicago, for instance, we can see the individual tests. That would be clearly more useful if some of them had failed, but you see that we're giving you that level of observability to sort that out. Okay, next, we're going to schedule the upgrade of our target sites. Now, you can manually trigger them, but if you want everything to kickstart beforehand, you plan your work and then you work your plan. So the best way to do that is to schedule this stuff. So it will start immediately at the onset of our maintenance window. So that's great. So we are going to set up our configuration and our plan here. So I'll go to our upgrade execution. And we will set up some parameters. We're going to software version 2409. We know where our license file is. We know where the software file is. We know what our parallel execution rate is. We know what our retry rate is. And we've got our node instances selected. Perfect. So we're going to wait until our maintenance window, and then this is going to occur. So once we kicks off, we see lots of things happening blindingly fast. More importantly, we can monitor the progress from the update dashboard. So when we're looking at this sort of thing, what we can be watching is really, just give me a second, here we go. Okay, so we see that there are a total of 501. There are 476 queued, so they haven't started yet. None have failed at the moment. 73 are in progress, and a few have completed. So the idea is eventually we want everything to be where it needs to be as this kind of concludes. There we go, 392, 498. Excellent. And our map comes online and everything appears to be green. Good. So the takeaway, fast and predictable upgrade of the network with full observability. So again, having visualizations and ability to monitor this stuff in a way that aligns with the needs of doing vast numbers of upgrades and updates is different than onesie twosies. So what works in your central cloud won't work on your edge. A high degree of resiliency due to automated procedures that expect a certain degree of failouts and failures, and of course policy-driven execution, which drives the cost effectiveness of the whole solution, getting you to a point where you can and will do this on a reasonably frequent basis to get those new capabilities to market. Okay, let's talk about some customers, because I mean, I don't want you to think that this is a theoretical exercise. So, Elisa is the customer we're going to be talking about. Elisa is a service provider in Finland. They have been doing quite a bit of work with us over the last number of months. In this particular example where we went through and they did an awful lot of measurements of how long it took them to do various activities, how much time they saved, how much effort they saved. What they were doing was a fully automated rollout of their CaaS platform up to and including their UPF node that they were deploying at the subclouds. So let me explain the chart on the bottom right. Now the color scheme makes it a little bit tricky to understand what's going on, but in each cluster, so each cluster represents an activity, an operational activity that was measured, and the far left of the cluster is the manual time. So that's the baseline. So it's always 100%. That's the thing we're measuring against. The middle bar represents the deployment time. So you can think of that as the duration. How much time, duration-wise, did we spend? And then the right-hand bar of each cluster is the automated operator time. So the operator effort. So that gives you kind of a couple of different ways of looking at the efficiency. So in the first one, user creation, we save 72% of the duration. And it looked like there's an operator involved all the time during the automation process. So we similarly save 72% of the operator effort. On the hardware audit, we save 66% of the duration and 85% of the audit of the effort. On the site preparation, and that which would include CaaS deployment and other helper apps like analytics and so on and so forth, we save 63% of the duration and 93% of the effort. And on the UPF deployment itself, 44% of the duration and 81% of the effort. And there is an application deployed along with the UPF to do monitoring of the N4 interface. So an 06 Polystar 06 application. We save 61% of the deployment of the duration deploying that and 96% of the effort. So there you go. Real world measurements that we were not actually involved with. So we're happy to see it, but they are completely independent from us. Verizon is another customer of ours. So Verizon uses Wind River's CaaS platform as the basis of their 5G vRAN network. It is the largest virtualized RAN deployment on the planet in production. Vodafone also uses Wind River software for its ORAN network. And so I will mention this. Wind River is not just complying and aligning with ORAN specifications, but we are very active in the OCloud and orchestration work groups. So we are key contributors to the definition of what's going on there. We are getting towards the end of our session this morning, so let's just kind of recap. I know I threw a lot of things at you. I know we went through a couple of demos and customer case studies and so on and so forth, but I really want to boil it down to a few key concepts. First of all, there is a difference between automation and automation at scale. That includes how resilient the solution is, that includes the observability that's provided, and so on and so forth. And automation at scale is absolutely what is required when we're talking about a edge network. Self-management, self-healing, self-configuration, the ability for the network to take care of a lot of aspects of itself is important to achieving the level of availability and performance and basic capability that is going to be required to satisfy this next generation of services, which are key to that 1,400% revenue growth, and then fast innovation. All of the good work that you're doing, all of the good work your vendor community is doing is kind of all for naught if it's not actually finding its way into your production network. And the faster you can integrate those capabilities, validate those capabilities, and push them out, the more competitive you're going to be in the market, and the bigger share of that 1,400% revenue opportunity you're going to get. And I definitely, we at Wind River, we definitely want you guys to go after that, and we want to be here to help you. So that, I think, is that for my presentation.
Thank you, Phil, for that insightful hour. We've got some questions. Phil, take it away with any of the questions that you have time to answer. And then if there's any other questions that don't get answered, you can definitely find the answers, reach out to Phil directly with his email, which is phil.ruckus@windriver.com.
Thank you, Abigail. Indeed, there are a couple of questions in the chat and Q&A, so I think we have just enough time to maybe pick those up. So the first one is from Emily, and she's asking if there's any online material to review, which might give a deeper understanding of how Studio is deployed. Oh my God, yes. So we have a plethora of materials. Not all of it is necessarily just publicly just generally put on our website, but we have more information than I can possibly describe in the remaining time in terms of dimensioning guides and planning guides and documentation and presentation information and so on and so forth. So if there is specific information that you're looking for, certainly please do feel free to reach out to me with your specific ask, and I will work with our teams to make sure we get you the information that is going to be useful to you in a timely manner. Another question from Paul. What are the limits to scaling of subclouds per system controllers? For example, can we run 15,000 national sites from 12 regional data centers? And would each system controller be 32 cores, 10 by 32 core sockets, a 47U rack of 32 core sockets? Okay. The scaling limits of work something like this. So it is currently 1,000 subclouds per system controller and thousands of system controllers per conductor instance. So it's a fan out kind of thing. So in your scenario of 15,000 sites, you would need 15 controller instances to manage that and one conductor instance. The dimensioning of the system controller, it really is a dimensioning exercise, so it depends on what you want to do with it and so on and so forth. But it starts, let's say it starts kind of the entry level controller package or recommended hardware begins at 2 or a dual Xeon 8-core kind of configuration, and then depending on what you want to do, we may recommend kind of expanding that. And I think we're currently up to 16 gig of memory, and there's some other requirements in there, but that gives you an idea of where controller scaling starts. Once again, if you feel free to reach out, and I could definitely get you some material in terms of sizing, specific sizing, dimensioning information, so you have a better appreciation for how exactly that works. And I can put you in touch with one of our solutions architects who can perhaps help to kind of formulate a deployment strategy for you. And I think that kind of gets us right to the top of our hour. So there you go.
Yes, Phil, thank you so much for the very informative hour and for getting through as many questions as you can. This has been very insightful. And as we said before, if there are any other questions, do feel free to reach out to Phil. I'm just putting it out there. I'm sure you'll be happy to answer any other questions that the audience may have. And thank you for everyone for tuning in for the hour.